Okay, so I think we can start. My name is Pavlos. I think some of you might know me. Some of you have met me in person. And thanks for joining this webinar regarding the Gusto tool. We're going to go through a presentation and then a demonstration. There will be sessions for questions and answers after the presentation and then after the demonstration, where hopefully we can have a nice conversation about the Gusto. And if some of you have already met the Gusto and used it, then you can give your feedback. To start off, the Gusto is can you hear me clearly? Right. There's a pending patent on the Gusto where you can see it here, and it's probably going to be released by the end of this year. To start off, let's start with what are POPP clamps, because that's what the Gusto tool is used for. POPP stands for pre-opened, pre-positioned clamps. These clamps come with, they're already glued on the pipe, on the pipe, and what the operators have to do is just insert the pipe into the inlet, which saves quite some time, and actually there is no much force needed from the operators to open the clamp and then release it. So as soon as the tool is used, these clamps go into the closed position with a large bang. So we can actually get the data and record this data and say whether this clamp has been successfully released or not. We can find these clamps in within the engine from the pipeline, the fuel pipeline system, and the return line up to the car thermostat and the cooling system. And especially now with automotives are releasing, when automotives are releasing electric cars or hybrid cars, then we have extra POPP clamps to be used. These clamps can vary in sizes and the way of release. So on the left-hand side, we can see the smaller clamps that they are closing on top of the pipe, while on the right-hand side, we can see different clamps that we call them big clamps, that they have a loop that helps the spring being open in the open position all the time, unless someone presses it close. Instead of size as well, they differ in material. So all of this is to say that we have a lot of different scenarios here. We can have smaller clamps, bigger clamps, different hoses, different hose to clamp ratios, and also different material on the clamps themselves. And also, having said that, any tool that is used on these clamps requires different force depending on the clamp, or different, and these clamps produce different vibrations. So this is a close-up of how the clamp is being closed. It goes into the closed position when the tool is engaged within the ear of the clamp and pushes this little piece of metal down. Then the clamp closes, goes into closed position. Now, I want to talk about the features of the Gusto tool. So we have three modules. We have the charger, the tool, and the receiver. The tool itself is the smart part, in the sense that it has all the clever algorithms or the sensors, and it sends all the data back to the receiver. It comprises 6 axes in inertia measurement unit, which there are 3 gyroscopes and 3 accelerometers in all 3 orientations. So with this, we can measure the acceleration and the degree, the rate of change of degrees. So that gives us an estimation on how the operator uses the tool, in which orientation and what kind of movement he does, as well as the vibrations coming via the tip towards the sensors. We've made this tool so that it works for all clamps. So there is one code for all the clamps and all the stations. There is also a built-in diagnostic menu, which the maintenance team can access in order to see how the tool performs. And the maximum distance between the tool and the receiver is 15 meters. Although these may vary depending on how noisy the station is or how many metal objects are around the station. And also, yes, the reason why people buy this tool is the ability to detect and reject accidental false triggers. In terms of hardware, we also have the receiver module, where there are the places of interest is the front panel and the back panel. At the front panel, we have indicators for the operators, and on the back panel, we have error-proofing inputs and outputs. To talk about the front panel a bit more, we have the clamp LED, which indicates whether a clamp has been successfully released. We have the low battery LED, which regards the tool, whether the tool is has low battery or not. And then we have the tool present. Now the tool present gives us an indication on whether a tool is connected to the receiver or not, any tool. As we might have different tools working within proximity, then we can have 64 available channels in order for them to communicate with the dedicated receiver without any interference. So that means that we have 64 different frequencies that the tool can use to transmit towards the receiver. And that means also that 64 different tools can work nearby to each other. At the back panel, we have an error-proofing output. So this can be connected to the plant's system in order to record the OK signals coming from the tool. And also on the right-hand side on PL2, we have an optional output for a light stack or any other indicators that the operator needs to have access to. We also have an RS-232 port, which we are going to talk about later on. The charger is simple as that. It does what it says. It charges the tool. We can attain 80% of the charge capacity of the battery of the tool within less than an hour. There are separate LEDs on the charger, which indicate the power on of the charger itself. And also there are indications on whether the tool is being charged on this charger. And as soon as the battery of the tool is full, then there is a separate indicator for that as well. You can see the green LED here. Also, the chargers work both in 110 volts and 220 volts AC. Now I'm going to show you a video of the individual features for the Gusto tool, and then we are going to explain these features one by one. Right, so why use the Gusto tool? Let's start with traceability. We have the ability to successfully record the data coming from a released clamp. And this is the accelerometer data and the gyroscope data, really. So when we record them, the plant can have access to them to see what is going wrong, if something is wrong, and also to get an idea of what kind of responses we get from the clamps. But also this might help us in order to make the Gusto tool even better in case there are some data that need to be recorded. These traces can also be displayed in a screen, but this is only for the Wi-Fi receiver, which it's currently under development. In terms of durability, for those of you who know the previous Gusto tool, it had a plastic charging cap at the bottom. We've increased the durability by introducing a full metal body. So this kind of body can withstand a lot more than the previous tool could withstand. In terms of the tips, we have hardened tips that can withstand 65 kilograms of quasi-static load, and they have high surface roughness, which allows them to last for up to 6 months. The PCB inside the tool, which does all the magic, comes with 1-year warranty, and it is upon replace. Then if it's going to be replaced within the first year, then this warranty is expanded. So we can actually guarantee you that it will at least last for 1 year. Now the state of these tools, when we sometimes get them back for repairs, it's kind of dreadful. We can see a lot of damage on them because they're hand tools. So we're talking about an environment which is really difficult, but still these tools were able to withstand these kind of harsh environments. It is operator friendly. We've tested this Gusto tool in 100 stations with good feedback in terms of handling from the operators. Compared to the previous Gusto tool, we've increased the width and the thickness by 5 millimeters, which is not that significant. And the length was tested again with against a lot of people that used this tool, and we got good results. So in terms of the radio channels, we have, on the newest Gusto, we have 16 different frequencies, but then we can use 64 different tools in close proximity without any interference. And this is done with some low-level encoding of the message that we've sent. Different frequency choices actually lead to different algorithms running within the tool. So we're going to later on discuss about the different tips that we have with the Gusto tool, that they are approved by MUBIA, and they can be accessed, the different algorithms depending on the tip can be accessed via bank and channel switches. These are some photos that MUBIA provided us. There are common damages on the clamps done by non-approved tips or different operators that they didn't operate the tool correctly. So you can see here that we can have either the middle pin damaged or one of the two sides of the loop damaged. And this actually can if the clip is damaged, that doesn't mean that the constant force is acting from the clamp to the pipe, but still there is a damaged clamp on a car that is going to be sold to a customer. So all of our tips are approved by MUBIA for this reason, so that this effect is minimized, if not there anymore, to be honest. The tips themselves go through plastic deformation before they fail. For example, if they are used for 6 months, they will eventually go into plastic deformation so that the maintenance team knows that they need to be replaced. And that is done for safety reasons. So when a tip is in plastic deformation, the operator should change it rather than continue to use it. If it didn't go into plastic deformation, chances were that it would create some sharpnel and that they would be hazard for the operators. In terms of different tips that we talked about, we have currently 6 different tips. And there are some variations amongst them as well. So we can have differences regarding the angle. So we can have 20 degrees angle, 0 degrees angle, and then 90 degrees angle. And then we can have differences in terms of length. So we can see here the 92 millimeter tip compared to the 60 millimeter tip on the left. And we can have differences on the ears as well. Regarding the number of ears we can have 2-ear tips or 3-ear tip. And also on top of that, we can have flat ears that they are better for, easier for the operators to release the small clamps that we talked in the second slide. These all can be ordered from Clavis, and they can be, the usage depends on the accessibility of the station. So for example, if there's no good accessibility in one station, the maintenance team can change the tip to the long tip or the 90-degree tip for easier access, which we're gonna later on show on the demonstration. So the battery of the Gusto tool can last for 4 days, and this was measured for based on 2,000 cars per day and 7 clamps per car. The full charge capacity can be attained within 3.5 hours, but as we said before, the 80% of this charge capacity can be attained within the first hour. There are also some smart features, which are the sleep and charging sequence, that they maximize the battery life. So whenever a tool is inactive and is not used by the operator, it goes into sleep mode to save some battery. So when the tool has low battery, it is indicated by the tool with a red LED flashing. So the operator has 5 minutes to put the tool on the charger and pick another one. There is another indication on the receiver side for the low battery as well, as we discussed before, so that the operators can see it on the system. Once the tool is placed onto the charger, the charging sequence starts with an orange LED indicated by the charger, as well as an orange LED by the tool. As soon as the tool is placed into the charger, communication between the tool and the receiver is ceased, so that the operators can pick another tool and continue working on the station. Regarding the tool communication, we can see that we have 2 switches on the receiver and another 2 switches on the tool. In order to pair a tool to the receiver, they need to share the same bank and channel combination. Now, we have different tips, as I said before, and they can be accessed via different combinations. They are stated within the manual. From bank, on the left is the bank. From bank 0 to 3, we have the short tip, 2-ear and 3-ear. From bank 4 to 7, we have the long tip. And from bank 8 to B, we have the 90-degree tip. So because we are using vibrations in order to detect a released clamp, we have different vibrations coming from different tips. So the algorithm needs to be changed. And in order for the maintenance team not to waste time and reprogram each tool each time that the tip is changed, then we came up with this solution that it is straightforward. As we said, this is a wireless device, so the communication between the tool and the receiver is done wirelessly. Here on the picture, we can see the Wi-Fi receiver, which is under development for the moment, which can transmit data in 2.4 and 5 gigahertz, depending on what the plant needs. There are, in terms of the radio receivers, that they are the standard ones for the moment, we have 434, 868, and 963 megahertz. So some of the plants have some restricted frequencies, so that's why we have a lot of choices in terms of the frequency of transmittance. For all of our receivers, we have a guaranteed maximum range of 15 meters. But as said before, this depends also on the obstacles that we might have in between. Now, when we say two tools work in close proximity, we mean that two tools are within 50 meters. So the tool can still transmit within 15 meters of distance between the receiver and the tool, but we cannot guarantee that 100% of the clamps are gonna be received. For plant connectivity, we have 3 options for the standard receiver, and these options do apply for the Wi-Fi receiver as well. So we have the most common one, which is the 3-volt contact relay, where the plant supplies the voltage that wants into the receiver, and it instead gets back a pulse coming via the 3-volt contact. The other option is for 24 volts pulse coming from the receiver directly, so the plant doesn't need to feed any voltage towards the receiver. And finally, we have an RS-232 message that we can manipulate depending on how the plant wants to communicate with the receiver. So we can send and receive messages via the RS-232 to determine whether a clamp has been successfully released or receive the vehicle in number from the plant. And that leads us to the error proofing part of it. When we are using the RS-232, we have the option to receive data from the plant, so we can actually get the data from the plant that this specific car requests 3 clamp to be released. And so the tool will send 3 OKs when this is done, and the receiver will only send 1 OK message towards the plant saying that 3 clamps have been released, instead of sending 3 OKs. So the tool really can provide a feedback regarding the car or regarding its clamp. Finally, in terms of speed, we have 0.3 seconds of delay between clamps. So the operator can use the tool and 2 clamps can be successfully released and that get detected by the tool if they are 0.3 seconds apart. So this provides a ease of mind for the operators not to wait between clamps for the tool to get ready. The quickest we've seen operators use the tool is 0.5 seconds. And I don't know if anyone can really beat 0.3 seconds. Now, if you have any questions, I'm gonna give you the ability to ask any questions that you might have. Yeah, so you can unmute and ask a question, or actually you can raise your hand and I will, after that, you can ask any questions you want. Right. So if we do not have any more questions, any questions really, what I want to do is I want to go to the demonstration, but before we do that, I'd like to show you the different type of tips that we have here. So, right. So I said before, we have 6 different types of tips, and they can be used in order to access difficult areas. For example, we have the 90-degree tip shown here, and ideally what it does is it offsets the tool away from the station and the engine so that the operators can have easier access. Similarly, with the longer tip, we can have the tool offsetted into the x-axis away from the engine itself or the station, really, where the operation happens. And then we can have 20-degree tips for the same reason, to offset the tool away from the axis of the hose. All of these variations can be ordered via Clavis, or actually, they can be ordered via Clavis, and they have different names that they can be ordered with. In terms of the tool, this is the frame that we've seen in the presentation. And really the three main components are a battery, the PCB itself, and an LED. So these are all replaceable, and again, they can be ordered via Clavis. Now on the PCB, we have the main processor here in the middle. We have the sensor on the top, which is the 6-axis inertial measurement unit. And then we have a programming port. So the programming port is for two reasons. They can be used for two reasons. We can either upload a new software release, or we can see what is wrong with the tool. So we can actually plug the tool into the via USB to the PC, and we can have a look on how the axis performs, or what kind of data we can get, and run tests for the LED and the rest of it. Now, there are some self-tests that can be accessed via the two switches here. The bank is, when we set the bank to F, and we have dedicated channels from C, D, E, that we can run different tests to make sure that the tool works correctly, so that there is no need for the operator to actually get the tool back to the maintenance team. Now we can go to the demonstration. Really, as we said, we have a plug and play approach. So for example, when we use the tool, it goes automatically into the charging mode. The tool is now asleep, so we can see there is no communication with the receiver. As soon as we pick it up, there is communication between the tool and the receiver. So we said about accidental triggers, that no accidental triggers pass, and then when we successfully release a clamp, we can see the indication on the receiver and also on the tool. So we have made this hedgehog, we call it, just to resemble the engine station. So Mo is going to demonstrate how to release clamps there. So these are difficult. There is a lot of difficulty in accessing these clamps, which is actually in reality what happens in a real engine. So as soon as the operation is finished, then the tool can be placed back into the charger, and the charging sequence starts with the communication being ceased between the tool and the receiver. Simple as that. I can see Joaquin has, someone has a question. You can actually go ahead and fire it.
Okay, do you listen to me?
Yeah, I can hear you.
Okay, you told that each time you have to change the tip, we should change the configuration of the tool. Is that true?
No. Whenever in a station, for example, if the 90-degree tip is used, so if the 90-degree tip is used in a station and we want to replace it with another 90-degree tip because the previous one was worn off, then we don't need to change the configuration of the tool. But if we are currently using the 90-degree tip and we want to change to a 3-year tip short, then we need to change the bank and the channel switches on the tool and also on the receiver. So,
Okay.
yeah.
So you're going to show us this issue, how to change if we must change the tip.
Yes. Do you want me to show you how to change the tips? Really, that's yeah.
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 I have little problems with that, with the PUTI application and the other application as well.
Yes, we can also, what we provide to our customers is support currently via WebEx, to be honest, because of the COVID going on. But
Yeah.
yes, we will definitely provide you with some guidance on how to do that via a WebEx. But for the moment, yeah, let me show you how to change the tip in 2 seconds.
Okay. The other question that I have is that I feel this tool too sensible to false shocks. I mean, for example, if I leave the tool over my desk, it receives an OK.
The receiver receives an OK, but the tool doesn't give an OK. Is that correct?
Is the receiver that receives an OK?
Yes, we have a specific program that does that. It's for other purposes, and we can definitely go ahead and show you how to fix that. So there is a specific dedicated program when accessing a specific combination between the bank and the channel, that without the tool sending any OK signals, the receiver receives them. Is that what you're seeing?
Yeah, I just want to know if how, because then I count the OK from the receiver.
Yeah.
Okay, because we have a communication between the receiver and our PLC. Okay.
Okay. Yep.
That means that if we receive false OK, probably that is not all the OK from the tool. The communication between the receiver and notary system is not correct. So I need that all OK that resides the receiver should be the correct ones.
Yes, that's why I wanted to set a WebEx with you to go through the bank and channels that you can use for this. This is not the correct program, the correct algorithm that runs within your tool, as it seems, because the tool doesn't say okay, and it just sends data to see if the communication between the tool and the receiver are okay, and that is all. So another algorithm needs to be accessed. That's all. But we can definitely go through that on our WebEx. So for changing tips, there are only 2 screws here that with the aid of an Allen key we can actually remove. For example, let's say that I have the long tip and I want to go from the long tip to the 90-degree tip. All we need to do is get these 2 screws out and then replace the new tip that we want. In this case, it's the 90-degree tip. We actually secure it down. And then all we have to do is go onto the bank and channel switch and change it for the 90-degree algorithm to run in the tool. So I'm gonna go and change the bank to 7, actually 8. And the channel is irrelevant. It actually determines which frequency to transmit at. What we have to do is we have to change the same switches on the receiver as well. So I will go ahead and change the settings there. So we are in bank 8, channel 0. And yeah, okay. So this is a different tool, a different actually tool that we're using. So yeah, so I'll go to bank.
For example, now I have open mine. It's the new titanium one. And I have a tip with 3 ears.
Mm-hmm.
Okay.
Yeah, that's
the
correct.
short one. So I should have 3 years.
Bank 0 to I would choose bank 0 to bank 2.
Bank 0, okay, is
Bank
correct.
0 or yeah, to bank 2 and any different channel, that's fine. But as explained to you, we're gonna go through this on WebEx. We can set a WebEx just to go through what needs to be done, and we can further explain on what kind of algorithm is running currently on your tool.
Okay. And for this kind of tip, 3 years tip, we can use both for releasing the clamp left ear and right ear, and also the top one.
Yes, that's correct.
We can do it in several ways. We can release it with the 2 lateral ears and also with the top one. The configuration from the bank is the same for all the way you do it.
Correct. So we have currently the bank 0 and 1 can run the short tips, and bank and the rest of the banks run different tips. So for example, if you set the bank to 0 or 1, you will have the ability to use the 3-ear tip with the 3 ears, no matter which ear you use. And yeah.
Okay.
Any other questions you might have? So yeah.
No, for me now
Okay.
it's just
It's just what we discussed. Yeah, we're gonna set the WebEx as we've discussed via email. Now, what I want to say is that with the current Titanium Gusto, we've used it. We can actually provide you with trial tools. They have all of the range of the tips available. We have all of the ranges of the tips available, and we're currently trialing it in at least 8 different plants. We had some really good feedback regarding the success rate. So on one plant, we had a success rate of 100%. And on another plant, we had 99.8% of success rate with no false positive acquired by the operation. Despite this success, we actually say that the the tool can perform at least 98.8% in terms of false, in terms of success rate, and then the false positive are less than 1% under normal conditions. So what was demonstrated before, this is not a normal condition, but we are trying also to eliminate that. So whenever an operator wants to false trigger it, he will have a hard time, at least, to say the least. All right. Do you have any further questions? I don't think I have anything else to add. Thank you all very much for attending. And if you have any questions regarding the Gusto tool or any technical things, you can actually email Clavis, admin@clavis.co.uk. The presentation is going to be given to you probably, and also the technical manual we can provide you with all the details that you might need. All right. Thank you very much again for joining, and hopefully we'll see you soon.